picture this. You are directing a massive live broadcast.
Oh, high pressure right from the start.
Exactly. The pressure is astronomical. You've got multiple 4K camera feeds coming in, and your entire ability to see what's actually going out over the air, well, it hinges on a tiny $1,555 metal box.
Right, which is wild to think about.
It really is. So our mission for today's deep dive is to decode exactly why a highly specific piece of pro-level gear, the AJA Hi5-12G-TR, is sitting right in the middle of your signal chain.
Because without it, you're flying blind. It's actively bridging the gap between those heavy-duty 12G SDI broadcast signals and, your standard HDMI 2.0 monitors.
Okay, let's unpack this. Why do broadcast professionals actually need this box? Like, why not just plug a camera straight into a TV?
Well, it's a fascinating bottleneck to look at. Without tools like this, high-end broadcast workflows would literally just hit a wall at the display level.
Because the connections are totally mismatched.
Exactly. We're talking about real-time translation between two completely different ways of moving video data.
Right, and when we talk about that 12G SDI connection, we throw around the word fire hose a lot.
It's an accurate word.
So let's look at why it's such a heavy lift compared to standard HDMI.
It really comes down to the uncompressed nature of the signal. So 12G SDI pushes 12 gigabits per second of raw, uncompressed 4K video.
Wow, 12 gigabits.
Yeah, and it's designed specifically for massive distance and reliability over a locking coaxial cable.
Right, which HDMI definitely is not.
No, not at all. HDMI 2.0 is great for standard display screens, but it requires all that data to be packaged and formatted differently. So this AGA unit isn't just swapping a plug shape.
It's basically doing math on the fly, right?
Yeah, it's actively repackaging a 12-bit 60 frames per second stream in real time.
And it's generating HDR10 metadata simultaneously. So it's like having a master UN interpreter who doesn't just flawlessly translate a fire hose of complex information in real time, but also perfectly preserves the exact emotional tone, which is essentially what that HDR metadata is doing for the colors.
That is a brilliant analogy, yes.
Yes.
Because without that real-time translation, your high-end broadcast monitor just displays a flat, washed-out image.
Just totally gray.
Pretty much.
Yeah.
Because it literally doesn't know how to interpret the camera's massive dynamic range.
Okay, so the flawless translation is handled, but on a chaotic set, a pristine signal doesn't mean much if someone, trips over a cable.
What's fascinating here is how this device manages redundant fail-safes.
Oh, this is the backup system.
Right. The Hi5-12G-TR includes an LC fiber transceiver alongside that standard SDI copper connection. So you can configure this video source auto switchover feature.
Video source auto switchover.
Yeah, it basically tells the box to prioritize either the SDI or the optical input.
Wait, so if someone on a chaotic set literally trips and yanks out the primary SDI cable, this box automatically catches the backup optical fiber signal to keep the monitor from going black.
It really does. Because it's actively monitoring both inputs simultaneously, the switchover is virtually instantaneous.
That's incredible.
Think of it like a redundant highway system. If the main bridge suddenly goes out, the data is already flowing on the secondary bridge, so your screen never drops.
Here's where it gets really interesting, though, and honestly, a little bit frustrating from a practical standpoint.
The physical toll.
Yes. Processing that much high-resolution, uncompressed data, monitoring the redundant inputs, doing the HDR color math, it's not just digital magic. There is a very real physical cost.
11 watts of power draw, to be exact.
11 watts for a box that's what, 4 by 4 inches?
Yeah, 4.6 by 4 inches, and it relies entirely on convection cooling.
Wait, so there are no fans inside at all?
None. 0 internal fans, which means the metal box itself essentially becomes the heat sinks. The source material actually explicitly notes it will become very warm to the touch.
Very warm. Which sounds manageable until you remember the constraints of the real world. You're telling me I can't stack these?
Oh, absolutely do not stack them.
In a broadcast truck or a server rack where space is at an absolute premium, having to space out a bunch of mini space heaters because they need ambient airflow feels like a serious design headache.
It is a spatial constraint for sure, but it's a necessary trade-off. If you stack them, that convection cooling fails.
Because they're just radiating heat into each other.
Exactly. They simply generate too much heat, processing billions of pixels a second. If you don't mount them somewhere with proper airflow, you risk thermal shutdown.
And nobody wants their monitor to shut down mid-broadcast.
Definitely not.
So, bringing this all together, the AJA Hi5-12G-TR really isn't just a basic cable adapter you toss in your kit bag. It's an active data processor, a vital safety net, and a translator ensuring pristine, uninterrupted video for professionals.
It's a great reminder of just how much hidden technology goes into simply putting a clear picture on a screen for you.
It really is. And it leaves you with a pretty wild technical puzzle to mull over. If crunching a 4K 60-frame signal today generates so much heat that you physically cannot stack these small boxes together, what kind of extreme thermal engineering is going to be required behind the scenes when the broadcasting world inevitably leaps to 8K or even 16K live transmission?